Everything we've said also works for DataFrames. So right here, with this DataFrame, we can say how many, right? The first thing usually is to start with an info method, right? So we have info, and we see that there are in total 4 entries, 4 rows. We can also do a shape if we need more information about the structure of our data frame. So there are 4 rows, 4 entries in our index. Column A has only 2 no values. So that means that there are 2 values that are actually no. There is column B that has 3 no values. So that means that 1 value must be none. And that's for column B again. So usually info gets you very close to understand the structure of your data frame and how many values there are missing. The same thing happens with sum. We can just do df.isNull is an A and then sum. And we're going to get a quick reference of how many null values we have in that given data frame. Drop an A works in the same way, but there is a significant difference. The way drop an A works in a data frame by default is by dropping any row that has at least 1 no value. So this row has a no value, dropped. This row has a no value, dropped. This row has 2 no values, dropped. This is the only one that it's not being dropped. Right? So it's very harsh in that respect. You can change that to make it to the column. Only keep the column that has no values. And that's by switching the axis equals to 1. And there is also a way to select a subset or threshold. So only delete rows that have less than 3 valid values, for example. In that case, you're going to use something like the strategy of the drop an A. You're going to say drop the columns, the rows, or the columns, because it is also works for columns that have all the values in null. Or drop this is the default behavior, drop all the rows that have any value in an NA. Or specify a threshold, which you are basically saying, I need this amount of valid values in order to keep the row. It's the way it works. Not which ones to drop, is which ones to keep based on the threshold. So once you have identified the null values, it's extremely simple to clean them, fix them. So the first method we're going to see is fill in A with a particular value. We're going to say from this series, I want you to fill the blanks or fill the missing values with, or fill the NAs, fill them with a number 0 in this case. So these two are number 0. Or of course you can use any statistical method you want. In this case we can use the min. Remember, this is not altering the series. The original series is still the same. We're not changing it. It's creating new series because all these methods are immutable. The following method is, the following way this method works is by passing a method, which is forward fill or backward fills. These are the possibilities. And basically the way it works is it's overflowing all the values top down, at least in forward fill, right? Starting here, it's dropping this value here, dropping this value here, and dropping now 3 here. As this thing is a none, it gets replaced. So this thing is 3 now, which gets dropped here, and now this thing is 3 again. So that's what we have right there. And of course, backward fills works in the other way. It starts with 4 and moves it here, and then moves it here, etc. You have to be careful when using this, because if you have null values at the beginning or the end, then you're going to end up again with null values because there is nothing to feed forward, right? This is the first value you have in there. And all we've seen also works for data frames. So both backward fill, forward fill, both in terms of rows for filling, right? So we have these data sets. So we do forward fill row base, going to be 1, 2, 2. Here 2 and then 5, right? So that's going to be forward fill axis 1. If you use forward fill axis 0, then it's a vertical filling, right? It's going to go here 1, 1, 30, 30. So that's for the column that is right here 1, 1, 30, 30. So it's either forward filling in this direction for filling, or it's going to be in this direction, depending on the axis that you are passing. And actually, we're gonna put the correct forms. With axis equals 0, it's gonna be columns, it's gonna be this direction. With axis equals 1, it's gonna be row based, so it's this direction, right? So we had a null value here that got filled in this way. Okay, moving forward, what else we have? We have here checking for values, and we've pretty much seen this already. You can use the isNull, the sum method to get how many values you have, and there is also any and all, which will give you very quick. These are usually called Boolean tests. You can ask if there are any values that are valid or if all the values are valid. It's just to build more complicated queries. So far, so good. So the process we said was at the beginning we were fixing missing data, missing values. There is nothing in there. We have read a data frame. Where's our data frame? Right here. We have read our data frame from a CSV, from a database, and the value is missing. No, there's a hole in it. So we have quickly identified it with isNA or isNull. We were able to drop the ones we didn't want to keep, drop an A, or we were able to fill the values we wanted to fill an A. That was simple. isNA, drop an A, fill an A. What happens when you're cleaning data that actually has a value, so there is nothing missing, but those values are invalid. So for example, here, the sex column is a categorical column that only accepts M and F. D and question mark, those are invalid. It's very simple to see an invalid value here because it's completely out of the scope. The same thing as we have, for example, a question mark in the age column, or if we have a string in the age column. It's very simple to identify that. How are we going to clean those? Let's start with sex first because it's simpler in this case. The first check we can do is with either unique or with value counts. I'm going to use value counts. We've seen this method before. It's a quick summary of all the unique values you have, and in this case value counts also gives you a total count for those values. How can you fix them? Well, there is a replace method which is extremely intuitive. You can just replace. In this case we're changing all the D's to F's and all the N to M's, and it can work in multiple columns. For those values that again we said were more complicated to fix, like in this case we know age in this case is 290, and we know, because we know the domain, that 290 is an invalid age for a human. So we will need, usually in those cases, we're gonna need more complicated fixing, and it will involve more programming. That's the reality. You have to be better at coding. In this case, we know that this value is invalid because it's probably an extra 0. So all these values, you are pulling a CSV with ages, and there are a ton of 180, 290, 32, 320, for example. Invalid values out of 100, right, in the 100 places. And that's because there were typos when they were creating the ages. So how are you going to fix that? Well, in this case, it involves a little bit more programming. We're dividing everything by 10.